Today we're talking about permutations and combinations. We're continuing our unit on probability, and we're looking at counting methods because we have to find the number of ways that you can choose objects from different sets. You can't find the probability if you don't know the total sample space, the total amount of outcomes. So we've already done the fundamental counting principle. We're just going to repeat this a little bit, review it a little bit, because it's still part of our understanding of probability and permutations and combinations, and we have to decide when to use which one. So the one we've done so far is the fundamental counting principle, which says that if event M, I think you'll remember doing this, can occur M ways, and event N can occur N ways, then event M followed by event N, that just means they happen in succession, first M, then N, can occur. And I apologize that I made a mistake in the notes here. This should be a multiplication symbol, not an add. Can occur M times N ways. So basically, I'll just leave it like that. So an example of that would be a menu with 4 entrees and 6 drinks. So remember that we said if you've got 4 outcomes that happen 6 ways, then we just multiply 4 times 6, and we get 24 possible lunch specials. That we did a lot of when we said, like, you've got to pick out a shirt, pants, and belt out of 5 shirts, 3 pants, 2 belts, something like that. You would just multiply because you're just seeing how many possibilities there are. So for our permutations and combinations, we need to learn something called a factorial. And I believe this is the first time you've been introduced to this. You'll use it in future math classes, but I don't think you've used it yet. So what we call a factorial is the product. What does product mean? It means multiply. So the product of the integers, that's whole numbers and their opposites, from 0 down to 1. Now that I think about it, I'm not even sure why we say integers instead of whole numbers, but that's a conversation for another day. So you start with n, you multiply it by n minus 1, that's the next one down, then the next one down. So I think you'll see this better with an example. So 4 factorial means, now factorial, that's the exclamation point, that means factorial. 4 factorial means 4 times 3 times 2 times 1. Then you multiply that all together and you get 24. The reason we need to know a factorial is that it's part of our fundamental counting, permutations and combinations. I've been sick, so I'm stumbling over my words here. Forgive me. So the any kind of counting method is used to find the number of outcomes, as we said. I'm sorry, I'm trying to get my notes ready. So a permutation is an arrangement of items in which the order, this is important, and this is important, that the order is important. So for a permutation, and I should have put this in the notes too, n items of a set arranged, n items of a set arranged are items at a time. I realized I didn't define N and R here, which would be a little confusing. N items of a set arranged R items at a time. You can see why order matters, because this is how many orders they have to be in. So here's your notation. I know you haven't seen anything like this before. So you've got P standing for permutation. The permutation of N items arranged R ways is N factorial over N minus R factorial. Now, the R can only be between 0 and N. You can't arrange it more times than there are items, and it has to be bigger than 0. One little aside that I didn't mention up here, it's not real important to us right now, but just so you know, 0 factorial equals 1, and I'm not going to explain that right now. All right, let's do an example of permutation. So this means I have 8 items arranged in 3 at a time. So I do N factorial, the first number's the N, 8 factorial, over N minus R factorial. So the R is the 3. Now, by definition of factorial, I go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Does the 1 even matter? Multiplying by 1 doesn't change anything. Then 8 minus 3 is 5, so I have 5 factorial. 5 times 4 times 3 times 2 times 1. Now this isn't as hard as it looks, because I'm going to cancel the 1, the 2, the 3, the 4, the 5, and all I'm left with is 8 times 7 times 6. And 8 times 7 times 6 is 336. That means if I had 8 items that I could arrange 3 items at a time, 336. Let's say I have 8 students, and we're going to get a first, second, and third for our order of working a problem on the board. So we've got 8 students I want to arrange with a first, second, and third. That would be weird. I just made this example up. That's what this means. All right, a combination. How's a combination different from a permutation? You can probably guess based on what I said above when I told you that it was very important that order is important. So a combination is arrangement of items in which the order is not important. So this would be, I'm going to randomly pick those students to work a problem on the board, and order doesn't matter. An arrangement where order doesn't matter. So this N and R is N items chosen R at a time. So do you see the difference? Arranged is the different word up here. They're arranged R items at a time. And here they're chosen R items at a time. The order doesn't matter. So small difference. All right. So the combination of N items randomly chosen R at a time is N factorial over R factorial times N minus R factorial. Do you see the difference? The only difference is the denominator has that R factorial there. So for this example, we're going to do, this is a 9, in case you can't read that. I couldn't read it, a 9. So following this, I'm going to go 9 factorial over 4 factorial, 9 times 9 minus 4 factorial. All right, so this would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. over 4 times 3 times 2 times 1 times, what's 9 minus 4 is 5. 5 times 4 times 3 times 2 times 1. Now you're going to notice once again that the 5, 4, 3, 2, 1 cancels. Seems like maybe parts of this are going to cancel every time. So then you've got 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1, and that's 126. Wouldn't it be really cool if the calculator had a function that would do permutations and combinations for you? Guess what? It does. And let me go grab my calculator real fast. I hope you were grabbing yours while I was grabbing mine. All right, watch this. First, let's do this permutation up here. So this permutation we did was P, 8, N was 8, R was 3. Okay, hit the math button. Look across the top and see if you see anything that looks familiar that we might use. Oh, look at this PRB. Doesn't that look like a shortcut for probability? Which one's permutation? The one with the NPR? All right, what do we have on this side? An 8, arrow over, a 3. Enter. Oh my goodness, we got the exact same answer. This didn't exist when I was teaching in the caveman days. Isn't this cool? Okay, let's do the combination. So let's hit math, probability, and go to 3 for combination. What do we have in front? Whoops, 9, arrow over, 4. Oh, did we get the same answer? Pretty cool. Thank you, Ms. Jones, for a shortcut. All right, now the hard part. And I will tell you that sometimes these are very difficult for me. So we're going to work through it together. We have to decide, are we using the fundamental counting principle, permutation, or combination? A deli offers a lunch special, which includes, oh no, there's a typo. There's not an E at the end of sandwich, which includes 1 sandwich, 1 side item, and 1 drink. So your lunch special has to have all 3 of those things, 1 of each. Does it matter on the order? I would think this can't possibly be a permutation because order doesn't matter. If the deli offers 6 sandwiches, 4 sides, and 5 drinks, how many different lunch specials are possible? For me, this one's easy because we can only have 2 numbers in permutations and combinations, and this is 3. So counting principle, 6 times 4 times 5, 120 different lunch specials. All right, this is the one that gets me. This type of problem has me confused. You can download 8 songs on your music player. If the song's using the random shuffle option, how many different ways can the sequence be played? Okay, so if you think about this, you can't do 8 times 8 because, okay, first song, there's 8 choices. But after that song is picked, there's 7 choices. Then there's 6, then there's 5, then there's 4, then there's 3, then there's 2, then there's 1. So we did this with like the deli sandwich when we were using 2 different meats. After you picked one, you had fewer choices for the next because you couldn't repeat. It was different. Same thing here. You can't repeat that song. So we could do this way. Or for some strange reason, this works. Order matters, right? Because you can't repeat. If you did it as a permutation using an 8 on both sides, like I said, these confuse me. I don't really know why it works, but it does. So we can go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and we get that there are 40,320 ways those 8 songs can be arranged. But let's do the permutation. Let's go math, probability, permutation, and let's put an 8 on both sides of that. Oh, same answer. Kind of weird. All right. So let's go to the next one. Because this video is getting to be quite long, I'm going to skip around. Now, this number 3 would be the same as number 2. All right. Student council is electing president, vice president, and treasurer. How many different ways can they be chosen from the 10 members? All right, does order matter? It does matter, because once you're president, you're not considered for vice president. Once these two are, so order matters. Order matters here. So we're going to do a permutation. So we're going to do the permutation of how many total. There's 10 members. They're arranged 3 ways: president, vice president, treasurer. So let's go. Let's do the easy way: math, probability, permutation. Let's do a 10, arrow over, and do a 3. And there are 720 different ways the officers can be chosen from the 10 members. Now, be glad that permutations and combinations exist, because this would take us forever to sit there and write that out. Say, what if Sally was president and Bobby was vice president? And then, you know, this would take forever to come up with 720 different ways. All right. 12 swimmers compete in a race. This is the same as number 4. How many ways can they finish? First, second, and third. We're going to do the probability that 12 swimmers can be arranged 3 ways. I'll let y'all put that in your calculator. Suppose your school requires you to choose 4 books to read on summer vacation. You got to read 4 from a reading list of 12 books. How many different ways can the books be chosen? Does order matter? It doesn't say you have to read them in a certain order. So no, order doesn't matter. So we're going to do a combination, because order doesn't matter. 12 books, but you only have to read 4. So we're going to go math, probability, combination. Oh my goodness, what is, obviously that app has ads. I apologize because I didn't bring a yellow calculator home, so I'm using the one on my phone. So 12 possible books, you choose 4, and there are 495 ways you could pick the books. Okay. A service club has 8 freshmen. 5 of them, let's see, here we go, 8. That's a very small service club. 5 of them are going to be on the cleanup crew for the annual picnic. How many different ways are there to choose 5 members to clean up on the cleanup crew? Order doesn't matter. You have to think about it. It doesn't say in an order, like this one has the first shift, the second shift. That would be a permutation. Order doesn't matter. It's a combination. Combination, 8 freshmen, 5 different ways. And you do this. I'm going to let you put that in your calculator so the video isn't forever long. When shopping to buy a new car, Johnny decided to buy a Honda Accord. The Honda comes, good choice. Hondas are excellent cars. 5 different colors, 2 different sizes of wheels, and 2 different types of interior. How many options does he have to choose from? This would be counting principle, wouldn't it? 5 times 2 times 2, 20 different car options. I like counting principle. That's much easier. Okay, then we're going to do, there were 10 different fish in a pond. If Sally chose 3 of them out of the pond, how many different combinations are there for those 3 fish? They were nice and actually used the word combination here. 10 fish, she's going to choose 3. Order doesn't matter. I'm going to let you stick that in your calculator. 8 runners are running a mile race. How many different ways? Here's your 8 runners. How many different ways can they finish first, second, third, and fourth? Does order matter? Yes, because they're finishing in different orders, so it's a permutation. 8 runners, 4 arrangements of places. I'll let you put that one in your calculator because you're getting good at this. A teacher lets you, I love the way this is worded, a teacher lets you work 10 problems for homework out of 30. Wasn't that nice? How many different possibilities are there for students to choose 10 out of the 30? All right, right here, would order matter? Does it say they have to work them in a certain order? It does not, so it's a combination. 30 total problems. You can work any 10. Oh, just for fun, I want to do this one. Math, probability, combination, 30, right arrow, 10, ooh, 3 million, no, Miss Jones, 30 million, 45,000, I cannot do this. 30,045,015. That's why you don't start your commas at the beginning. There are 10 songs on the new Bruno Mars CD. If it is played on random shuffle, how many different ways can they be played? This one is like, which one was it we did on the front? The, can't remember which one we did. 10 songs. Random. So you could do it 10 factorial, basically 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or remember, we discovered that the permutation using 10 on both sides would work. Kind of weird. Well, all right. I'll show you that when I get back. Okay. By the way, if there are 30 million ways to choose 10 problems out of the 30, is the teacher going to get suspicious when you all pick the same 10? Low chance of that happening, yes. Okay, there's your lesson on permutations and combinations and counting principle.